I mean, if you don't have something available, you have
to do that.
Yeah.
Good morning, everybody.
Good
Hi, Mark.
morning.
Let's make my pretty face.
Hi. Hello.
Sabrina doesn't want to show us. She's too scared.
So this is the one I have collecting so far. This is for the vision and the speech for the HUI3 domains. And I have one question towards the data set because, for example, the severity they had documented in the paper, it's like it doesn't have like for example like 6 level to mapping up. So I just read the description for each level and I try to just guess it. For example, like this severity it match this description for level 3 and I just mapping on that. Is that okay for that? Oh, sorry.
Mark, you're muted. Mark, you're muted.
You can see my pretty face and see that I'm talking. Yeah, that's fine. Yeah, it's exactly the way to do it. And I think that in terms of getting it right. So I think part of one of the things to explore in your discussion when you've done this is when you actually get the estimate for utility of the disease using this approach and compare it with measured using the actual questionnaires. And it's probably worth looking. So one of the things, and actually, I'll tell you where this, what the approach for that is called is the sensitivity analysis. So what you do is you pick the ones you think are best, but you also do like a scenario where you put them all in the lower and all in the higher. And then that gives you this is what you think it could be. This is a range that makes sense if it was all higher utility or all lower utility.
Okay. For example, if like the severity they have documented, for example, this are the 3 severity, like like this three are the severity that was stated in the papers. And because like I don't think this 2 level have any like description matching towards it, then I just put a 0 towards this like prevalence on those 2. Is it that how we do it?
Yeah, exactly. So that's the way you do it for your central estimate. But then what you do, for example, this I guess this other one that's like partial. What does that say? Hemolopia. That like partial. What you could say that is one lower or one higher.
Yeah, that's the problem. Because like this is more
right.
like
so what you do is that this is your central, but then you actually generate a patient set where those that could be higher and lower. First of all of them are lower, and then you generate what does that look like as an outcome? Then you do them, all of them are higher. What does that look like as an outcome? And then that gives you the central estimate with a lower and upper range.
Gotcha. So for now, because for a lot of the data
what I would do is you do those is somehow highlight ones that could move up or down.
Okay, I gotcha.
Because obviously, if it's like none, and if it's like no symptoms, and the other one is no symptoms, then it makes no sense that it moves up and down. But if it's something like mild, that it could move up or down, then just somehow say this is one that's like I've assumed it to be this, and it could move up or down. Maybe just do that with a column of like. Call it sensitivity analysis, for example, and just put Y or N if it's one that needs to move up or down for sensitivity analysis.
Okay, I gotcha. And I think another problem I'm facing so far, the major part, is that it's not hard to find the prevalence towards the fixed timeline. Like for example, this one, the baseline, it's not hard to find it. But I think one I find it difficult is like towards the time changes, because I think that's what we needed.
So, my thought with this, and I will also bounce this off Milica and Tanya, is probably some kind of Markov model for this, for these ones, with some specifications, may be the right way to do it. But we also, I think, Milica, were you on the HTA? Yeah, it was when we did the Vorex A's, where we did like a table of what it is by day. So effectively, what we did was we did like this is the kind of like averaged level, but we had it several times with the time that value stopped being the value. But I think you have distributions by days, don't you? Is mostly what ChatGPT is giving you as these tables out.
Yeah, but like the value, it's coming from the actual paper. So like in the paper, they do document the number of the patients, which is good. But I think for example, for the stroke, only the speech and vision one have very clearly saying like the number of it. The other is more of like let me show you. It's more of like how many people have recovered from it, but like they didn't really specify the severity prevalence towards that. They do document the time changes, but like it's not
it's not particularly clear. So that is where these Markov models really kind of come into their own, where you have a transition